Since the late 1800s, the horizontal fire tube has been the leading design for boilers. It was used to power locomotives and steamships, as well as heat buildings with steam and hot water. Combustion occurred in a spacious chamber, and heat was directed through a series of tubes immersed in water and supported by tube sheets on either end. The water outside the tubes absorbed heat gradually, producing a reliable and controllable supply of steam, or hot water. This design became the industrial standard for heating applications. Horizontal fire tube boilers not only worked well, they could also be serviced and maintained over several decades, ensuring longevity. All of that changed, however, with the introduction of the vertical fire tube condensing boiler, chasing efficiency with no regard for longevity or service. The vertical orientation created its own category of fire tube and severed ties with what worked so well. Although vertical models work on the same principle as horizontal models, their smaller size has altered heat absorption and introduced several design flaws. Heat is no longer gradually absorbed, it's blasted directly on material, and all heat transfer is forced within the limited height of the tubes. The burner is now oriented on top of the tank, close to one of the two tube sheets supporting the tubes. This sheet sits above the waterline, while the opposite tube sheet is below the waterline, farther from the burner. This results in a temperature differential that, over time, produces greater top sheet radial expansion, leading to strain, growing tubes, and thermal fatigue on the tubes and their welds. There's no room for expansion or contraction. The burner's heat is also concentrated at the center of the tube sheet, leading to a type of thermal deformation known as diaphragm bending or oil canning. When the boiler operates at reduced firing capacity, heat follows the path of least resistance, moving through the center of the fire tube assembly and creating static pressure differentials, known as zombie zones, that further contribute to stress and deformation. Still, another source of stress comes from entrapment. The vertical orientation traps air bubbles beneath the upper tube sheet and low point, collecting debris within the vessel. This diminishes the transfer of heat in some areas, while leaving hot spots in others. Moreover, servicing and maintenance are nearly impossible. There is no access for tube cleanings, debris removal, or waterside service, and no repairs can be made to tubes or tube sheets. This has led to an attitude shift in the boiler industry, from maintain and repair to dispose and replace, which means higher operating expenses, capital expenditures, and poor life cycle analysis with vertical condensing designs. We bring access to the heat exchanger and burner for service and provide the industry's only field repairable condensing boilers. We also provide knockdown configurations to place high efficiency anywhere. We brought boiler features back to condensing applications, a common sense approach beyond the vertical limits of condensing fire tubes. Learn more at bryanboilers.com.